Hi, this is section 14 in our class, and we're going to pick up with the prep skills. I think I mentioned this before, but because we're going a little bit out of order, sometimes we might repeat some prep skills, but I don't think there's anything wrong with that. They're usually pretty quick, and it never hurts to review some of these basic things that we might need in the upcoming section. So the first thing that we're going to look at here is adding integers, which means adding positive and negative numbers that don't have a fraction or a decimal part to them. So we're going to start with 12 plus negative 3. And it's just a reminder that, remember, when you're adding a negative, it's the same thing as if you're subtracting, or vice versa. If it's easier to switch a subtraction to adding a negative, you can always do that. So 12 plus negative 3 is the same thing as 12 minus 3, which of course is 9. And then we have 15 minus negative 8. When you have minus and negative, the minus and the negative undo each other. If you think about what a minus does, if you're starting at a minus, or starting at a number and then you're subtracting. So say we're starting at 15, and we want to, let me move the 15 down towards the middle a little bit more. So say we're starting at 15, and we know that we want to subtract, then we know we're going to go this way. But we're not subtracting a positive number, we're subtracting a negative number. So basically what it does is it says, hey, we're going to go this way when we see the minus sign, but then we see the negative and it says, oh wait, no, we're going to go this way. So they kind of undo each other. I always used to joke with students that, I still do actually, that it's kind of like the cha-cha slide, that minus and negative is kind of like the reverse in the cha-cha slide, that it tells you to turn around, but then it tells you to turn right back around again. And so what you end up doing is just going the direction you were going to begin with. So 15 minus a negative 8, long story short, is the same thing as 15 plus 8. And that is 23. So we're going to go this way, 8, which gets us to 23. When you take multiplication and division, if you're going to multiply or divide, if you have an addition or a positive and a positive, that's going to get you a positive. If you have a positive and a negative, or a negative and a positive, that's going to give you a negative. And then if you have a negative and a negative, it's kind of like up here again. You're taking two negatives here, then you're going to end up with a positive overall. It's a little different than the adding and subtracting, because this, when we end up with that positive, it's telling us what direction to go. Here it's telling us our overall answer is going to be a positive. So now we have 12 times negative 5. Since we have a positive and a negative, we know the final answer is going to be a negative, and then we just multiply. 12 times 5 is 60. Negative 84 divided by negative 7. The two negatives are going to give us a positive overall, and then 84 divided by 7 is 12. So our answer is positive 12, or of course we can just write it with as a 12. We don't have to put the positive in front of it. When we're adding or subtracting fractions, we always want to have a common denominator. If you start with those, 3/7 and 2/7 already has a common denominator, then we can just add the top. So we have 3/7 plus 2/7 gives us 5/7. If you think about it with some of the things that we're used to looking at with fractions, take a I'm not going to try to split a pizza into 7 pieces. So we'll split it into 6 pieces. Imagine those are all equal size. I'm not doing a very good job of drawing that. But if I had, say 1/6 of the pizza, and we wanted to add that to 3/6 of the pizza, then we would have 4/6 of the pizza. So we'll add it. There's my 1/6, there's my 3/6, and overall I have 4/6. Of course, 3/6 can be reduced to a half, 4/6 can be reduced to 2/3, but we're talking about what do you do if you have two fractions that already have a common denominator. You take the tops and you add them, and the bottom remains the same. So 3/7 plus 2/7 is 5/7. Same thing when you subtract. If you have 8/3 and you take away 2/3, you're going to end up with 6/3. But 6/3 is 2, because 6/3, here's 3/3. 6/3 means you have wholes that are split up into thirds, and you're taking 3 of them. So, or this would be 3 of them. So 3/3, and here's another 3/3. So this is 6/3, but 6/3 is the same as 2 whole items, whatever those items are. When you're multiplying, you're going to multiply across the top, multiply across the bottom. They're specifically talking about it if you want to write a new denominator. So if we want to keep 2/3 the same value, but we want a different denominator, if we want to multiply the bottom, say, by 4 to get a denominator of 12, as long as we multiply the top by the same thing, this will still be an equivalent fraction. So 2/3 and 8/12 are equivalent to each other. We've just changed the denominator to 12. So in this last one, let me work it over here. If we have 3/4 and we're subtracting 5/6, we want to have a common denominator because we can't subtract these unless we're subtracting the same thing. Otherwise, it's like trying to subtract apples from oranges and call them apples or oranges. We can't do that. We would have to find something in common, for instance, call them fruit. And so that's kind of what we're thinking of when we're talking about denominators here. We want to come up with something that they have in common. Well, they both go into 12. And so if we take 3/4 and we multiply the top by 3 and the bottom by 3, that'll give us 9/12. Same thing here. If we take 5/6, we want that 12th on the bottom, so it's the same as this one. If we multiply by 2, we're going to get 10/12. And this one's kind of unusual because we have a fraction and we have a negative. Because if we take 9/12 minus 10/12, that would be 9 minus 10 over 12. 9 minus 10 is -1. So we have -1/12. So if we have 3/4 and we take away 5/6, you're taking away more than what you started with. 5/6 is bigger than 3/4. So now we're on to the to skill 3, which is adding decimals. We have 2.3 and we want to add 0.5. So I'm just going to write it like you would if you were hand adding these, one above the other, so we can get things lined up. So 3 and 5 is 8, 2 and 0 is 0, and then of course we're going to put the decimal in the right location. And then if we have to carry, we carry just like we do if this was 35 plus 59. We do 5 plus 9 is 14. 5, 6, 7, 8. We add this 1 that we carried, that's 9. And then the decimal would go there because this is the tenths place and ones place rather than the ones in the tens place. So next we're going to do these prep skills questions, and I would recommend as always that you pause the video now, try to do these problems, and then see how you did. So I would pause the video and do all 4 of these sets of problems and then turn the video back on. Okay, so hopefully you've done that. And first we have just 12 plus 4, which of course is 16. Hopefully they didn't trick you into thinking that was something more complicated. Next we have 8 plus -10, which would be 8 minus 10. So you're taking away more than you started with. If you start at 8 and you go down by 10, taking away 8 would get you to 0, and you're taking away 2 more than that, so you're down to -2. If you want to think of it on a number line, we're going to start at 2, 3, 4, 5, 6, 7, 8. We're going to start at 8 and we're going to subtract 10. So we're going to subtract 8 and then 9, 10. So we're at -2. And then for the next one, we have -5 minus -7. The biggest thing with this is to recognize that minus the negative is going to give us a plus, so negative 5 plus 7. And if we're down by 5, there's 4, 3, 2, 1. If we're down by 5, if we come up 5, that gets us to 0. But we're actually coming up 7, so we're coming up 2 more than that. We would be at 2. Positive 2. Okay, for number 2, we've got 4 times 6, which of course is 24. We've got, that was A, and then B, we have negative 8 times 4. Our answer is going to be a negative because we have a negative and a positive, and then 8 times 4 is 32. For C, we have 2 negatives, negative 12 times negative 5, and the 2 negatives are going to make a positive, and 12 times 5 is 60. So 60 or positive 60 or just 60. On this first one on number 3, we have already have common denominators, so 8 fifths plus 3 fifths would be 11 fifths. They're not requiring us to change that to a mixed number, so we won't do that. For B, we have 2 ninths minus 23/36. We're going to look at what 9 and 36 both go into. Well, they both go into 36. So I'm going to leave the second one alone. And then the first one, I want to make the bottom a 36. So how can I do that? Well, if I want to take and make the bottom 36, I got to take the 9 times 4. But if I do that to the bottom, I have to do the same thing to the top. And so the top becomes 8/36 instead of 2 ninths. Then when we try to take and subtract, 8 minus 23 is what we have on top. We're supposed to have that common denominator of 26, but 8 minus 23 is negative 15. And then last but not least, we have our decimals that we're adding. 8 plus 1 is 9, and 4 plus 3 is 7, so it's a 7.9. This is 0.3 and 1.9. Add those together, you get 12. Carry the 1, you get 2, so 2.2. And 0.36 and 0.77, we have 2 decimal places, but same process. 6 and 7 is 3. Carry the 1. 1 and 3 and 7 is 11. Carry the 1. And then 1 and 0 and 0 is 1. So 1.13.
Here we're given the items that are in a fourth grade girl's lunch and a series of nutritional information for each of those items, and we're asked some questions. So the first thing we're asked in number 1 is for the total calories in her lunch. So looking at this slide, her lunch consists of 2 servings of bread, 1.5 servings of turkey, 1 serving of cheese, a half serving of carrots, 1 serving of yogurt, and a juice box. So looking at the calories for bread, she's going to get 2 times the 66 calories. And then for the sliced turkey, she's going to get 1.5 times the 34 calories. And then for American cheese, 1 serving of that, so just the 60. Carrots, she gets a half serving, so half of 25, and then she gets 1 serving of yogurt, so 119, and then 1 juice box, so 60. And when you add all of that up, you get 434.5 calories. For number 2, we're supposed to look at total calories from fat. So with 2 servings of bread, that'd be 2 times 8 calories, 1.5 times the 5 calories for turkey, 1 times the 40 calories from cheese, and then a half of the 1 calorie from carrots, 2 calories for yogurt, and no calories at all for the juice box. And that ends up being a total of 66 calories from fat. In number 3, we're going to look at the total milligrams of sodium. So for the bread, that'll be 2 times 130 milligrams. For the turkey, it'll be 1.5 times 335 milligrams. We get 200 milligrams from the cheese, half of 42 for the carrots, 72 from the yogurt, and 10 from the juice box. And that comes out to 1,065.5 milligrams of sodium. In number 4, we're going to look at the grams of carbohydrates. So that would be 2 times the 12 grams for bread, 1.5 times the 1 gram for turkey, 2 grams for the cheese, a half of the 6 grams for carrots, 24 grams for the yogurt, and 15 grams for the juice box. And that gives us 69.5 grams of carbohydrates. In 5, we're supposed to compare the percentage of the recommended daily allowance for sodium versus calories. And so her lunch has 1,065.5 milligrams of sodium, and that's out of a recommendation of 2,300 milligrams per day. Well, that comes out to 46.3%. So this lunch gives her 46.3% of the recommended daily allowance for sodium. What about for calories? Well, this lunch has 434.5 calories out of a standard 2,000 calorie day, and that comes out to 21.7% of her daily calories. So it looks like if this is only 21.7% of her calories, but it's already 46.3% of her sodium, this lunch is very high in sodium. In 6, if we use the letter P to stand for the phrase grams of protein, then what's the result of this calculation and what does it mean? Well, this means 6 grams of protein plus 9 grams of protein and so on. These are the amounts of protein in each item in Charlotte's lunch, and if you add up the numerical parts you get 24.5. So this adds up to 24.5 P, which literally means 24.5 grams of protein. That's how much protein is in Charlotte's lunch. In 7, we're supposed to write the number of grams of sugar in Charlotte's yogurt and the number of milligrams of cholesterol. So let's look at the information from the yogurt. And there are 24 grams of sugar and 2 milligrams of cholesterol. And so then it asks what happens if you put a plus sign between those two quantities. Can you add them? Well, no, you can't, because those are amounts of two completely different things. So if you tried to throw them together and add the numbers together, it wouldn't mean anything. In 8, suppose in addition to the carbs already in her lunch, she also eats some pretzels, which add another 3,000 milligrams of carbs. So at this point, she's eaten 69.5 grams plus 3,000 milligrams of carbs. Can you perform that addition? They're both carbs. Well, no, not the way it's written, because grams and milligrams are different size amounts, so we cannot add those together. Okay, so in number 9, what if we know that there are 1,000 milligrams in 1 gram? How many grams then would 3,000 milligrams be? Well, if 1,000 milligrams is 1 gram, then 3,000 milligrams would be 3 grams. And so the question is, does that help? Now can we add the amounts? Well, yes, because now we have both of them in grams. So we can take 69.5 grams plus 3 grams and find out that now she's eating a total of 72.5 grams of carbohydrates. Here we're supposed to add the quantities if we can, and if not, explain why. In number 1, 12 grams of cholesterol plus 5 grams of cholesterol. Well, yes, those are both counting the same type of thing, and so we can add them together and get 17 grams of cholesterol. In number 2, 3/11ths plus 7/11ths. Well, in fractions, the denominator is the type of thing that you're trying to add. So we have 3/11ths plus another 7/11ths, so the total would be 10/11ths. In 3, 8 yards plus 2 feet. Well, those are different, so we can't add them the way they are, but we're able to convert those to the same thing. In this case, I'm going to change yards into feet. I know that there are 3 feet in a yard, so 8 yards is actually 24 feet. So what we're really adding here is 24 feet plus 2 feet, and that gives me a total of 26 feet. In 4, 10 grams of sodium plus 17 grams of carbs. Well, those are counting completely different things. There's no way I can convert one into the other unit, so I will not be able to add those together. In number 5, we have $5 plus 75 cents. Well, we can convert that to $5 plus $0.75, and that would give us a total of $5.75 or $5.75. You could also have converted that into cents if you wanted to. In 6, 8x plus 5x. Well, those are already like because they both have the x on them, so that would be a total of 13x. In 7, 2/5 plus 7/20. Well, those are not like units or like terms, but I can make them the same. So I'm going to convert them both to 20ths. I have 2/5 plus 7/20. I need to change the fifths into 20ths, so I need to multiply the denominator by 4, which means I need to do the same thing to the numerator. That gives me 8/20 plus 7/20, which is a total of 15/20. And with fractions, you do have to ask yourself if those reduce, and these do. I can divide both the top and the bottom by 5, which gives me a final answer of 3/4. In 8, 5 days and 5 hours. These aren't the same, but I can make them the same. The easier direction to go with this is probably to make them all hours. So there are 24 hours in a day, which means that in 5 days there are 120 hours. Plus 5 more hours gives me a total of 125 hours. In 9, 3y plus 7y squared. Those are not the same, and I cannot make them the same, so I will not be able to add them. And then in 10, 0.5 plus 0.4. Well, that's 5/10 plus 4/10. Those are like units, and so I can add them together and get 0.9. Here we're given a bank statement and asked some questions about it. The first questions are general. In 11, what does a credit refer to? Well, that's money deposited into an account. And then in 12, what does a debit refer to? Well, that's money that's paid out of the account. And then in 13, what is meant by a balance? Well, that's the current amount of money that is in the account. In 14, how did this account holder do this month if her goal was to spend less than she made? Well, let's go look at her statement. And her total credits are more than her total debits, which means she did well. She did make more than she spent. And then in 15, what would the ending balance be with an additional debit of $50? Well, let's go look at her ending balance. And that's $2,452.28. An additional debit of $50 would subtract another $50, which would leave her with $2,402.28. In 16, what would the ending balance have been if the account holder hadn't returned the shirt on April 26th? Let's go look at that. So on April 26th, she returned a shirt for $22.01. If she had not done that, then she would have $22.01 less than she does now, which would leave her instead with $2,430.27. In 17, what would the ending balance be if we remove the $200 cash withdrawal from May 8th? So that would mean on May 8th, if we remove the withdrawal, then it was never taken out, which means she would have $200 more, giving her $2,652.28. Here we're going to start summarizing what happens when you add and subtract positive and negative numbers. In 18, we know that credits add to the balance and debits subtract. What happens if you add 2 credits to your account? Well, those are both adding, so you would add even more. and your balance would actually go up by the total of the two credits. So in 19, that tells us that adding two positive numbers results in a larger positive number. In 20, if you add two debits to your account, what does that do? Well, debits decrease your balance. They subtract. So if you add two debits to your account, that means that your balance will decrease twice. So your balance will actually decrease by the total of the two debits. In 21 then, adding two negative numbers results in an even more negative number. In 22, so what if you add a credit and then follow that with a debit? Then what happens? Well, in that case, it depends which one was bigger. If the credit was larger, then the net effect is that your balance will go up. But if the debit was larger, then in the end, your balance ends up going down. And so then in 23, adding a negative to a positive is really the same thing as subtracting from the positive. And if you subtract a number that's larger than the positive one, you'll end up with a negative answer in the end. But if you subtract a number that's smaller than the positive, it'll stay positive. In 24, if you remove a debit from your account, what happens to your balance? Well, remember we did this with the bank statement. We removed a withdrawal, and that ended up increasing the balance because it was like the withdrawal never happened. And so in 25, subtracting a negative is the same as adding the positive of that number. Here we're still looking at some different things that can happen when you add and subtract with positive and negative numbers. In 26, suppose you have a balance of $1,200 in your checking account and you make a deposit of $210. Well, that means now you have $1,410. In 27, what if you have a balance of $210 and then you make a deposit of $1,200? Well, you're still going to have $1,410. In 28 then, that tells us that when you add two numbers, the order does not matter. Addition is commutative. In 29, suppose you have a balance of $1,200 in your checking and you make a withdrawal of $300, so that will subtract. Well, that's going to leave you with $900. In 30, what if you have a balance of $300 and you make a withdrawal of $1,200? So we're going to subtract the $1,200. Well, that's going to leave you in the hole. You're going to have negative $900 in that case. So for 31, what that tells us is when you're subtracting, the order does matter. You are not going to get the same answer if you switch the order. Subtraction is not commutative. So in 32 through 34, we're supposed to figure out which word tells us which arithmetic operation to use and then do it. So in 32, the sum of $4 and $2.50. Well, the word sum tells us to add. And so we'll go ahead and take $4 and add $2.50 for a total of $6.50. In 33, my GPA was 3.1, but it increased by 0.4. Increased by also tells us to add. And so we'll take 3.1 and add 0.4 to get a new GPA of 3.5. In 34, the difference between $3.50 per gallon and $2.05 per gallon. Well, difference tells us to subtract. And so we'll go ahead and take $3.50 minus $2.05 to get a difference of $1.45 per gallon. So then in 35, we're summarizing some of the words that tell you whether to add or subtract. For addition, you have plus is added to in addition, and then the two that we just learned, sum and increased by. And for subtraction, we have minus is decreased by, is taken away from, and then the one we just learned, which is difference. We're given a bar graph for 2 truck drivers for the number of miles that they drove each day for a week. In number 1, we're asked how far did Dwayne drive last week. So Dwayne is the blue bars, so we'll add all of those together. On Monday he drove 250 miles. On Tuesday it was 210. On Wednesday it was 190. On Thursday he didn't drive at all. On Friday it was 450. And on Saturday it was 200. And that ends up to 1,300 miles. In 2, it asks who drove the most overall. Well, before we can figure that out, we need to figure out how far Seabass drove. So those are the orange bars. We've got 490 plus 200 plus 0 plus 240 plus 120 plus 340, and that comes out to 1,390 miles. So comparing the two, it looks like Seabass drove more, and then by how much? So we'll take 1,390 and subtract 1,300, and that tells us that Seabass drove 90 more miles that week. Here we're given a bar graph about annual net profits and losses for Ford Motor Company. In number 3, what was the difference between the net income in 2008 and 2009? So to find that, we'll take the net income from 2009, which was $3 billion, and we'll subtract the net income from 2008, which was negative 15. Subtracting a negative is the same as adding, so that's the same as 3 plus 15. Which says that that is an $18 billion difference. And because that came out positive, that's an increase. In number 4, what was the company's total net income for the years 2007 to 2010? So we'll add the net income from each of those years together. In 2007 it was negative 3, plus in 2008 it was negative 15, plus in 2009 it was 3, plus in 2010 it was 7. And so adding those together we get negative $8 billion. And because that's negative, that's a loss. And then in 5, what was the total net income for all of the years? So we've got negative 3 plus negative 15 plus 3 plus 7 plus 20 plus 6 plus 7 plus 3 plus 7, and that comes out to a profit of $35 billion. In 6 and 7, we're supposed to find the perimeter of each figure. Now, when we look in number 6, the perimeter of a rectangle is found by adding all of the lengths of the sides together. However, in this case, we have different units on each side. And we know that we can't add those together unless they're like units. So we need to choose. We're either going to convert all of these to feet or all of these to yards. I'm going to go ahead and convert them all to feet. So 5 yards, there are 3 feet in a yard. So 5 yards is 15 feet. And the top and the bottom side then will both be 15 feet. Now I can go ahead and find the perimeter by adding all of those together. So I have 10 feet plus 15 feet plus 10 feet plus 15 feet, and that adds up to 50 feet total. In 7, we're finding the perimeter of a triangle, and again we have different units. So we need to pick whether we want to use feet or inches, and that's completely up to you. I can either take the ones in feet and multiply them by 12 to get inches, or I can take the one in inches and divide it by 12 to get feet. Since only one of them's in inches, let's go ahead and convert that one. So if I divide 30 inches by 12, that'll give me 2.5 feet for that side. That makes my perimeter 6 feet plus 5 feet plus 2.5 feet, which gives me a total of 13.5 feet. In 8, we know that the total perimeter is 86 inches, and so we need to find the length of the side that's not labeled. Well, first let's figure out what the total is for the sides that are labeled. We have most of these in feet except for the 10, which is in inches. Even though only one of them is in inches, I think I'm going to go ahead and convert all of them to inches because that's what we have the perimeter in. So 2 feet times 12 is 24 inches. 1 foot is 12 inches, and then we have another side that's 2 feet, which is again 24 inches. So I'm going to go ahead and add those up. 10 plus 24 plus 12 plus 24, which comes out to 70 inches. And that means that out of the 86, the sides that are already labeled are taking up 70 inches. So I can take that perimeter of 86 inches and subtract the 70 inches that are already accounted for, and that tells us that the missing side is 16 inches. For these questions, we're given an Excel spreadsheet with problem numbers, points possible, and the number of points earned by a student on a quiz. In 9, what percent of possible points did this student earn? Well, this student earned a total of 41 points out of a total of 50 possible. So 41 out of 50 comes out to 0.82, which is 82%. In 10, write down all of the numbers that were added to calculate the value in cell C12, so that 41. Well, all of the numbers above it in the column were added together, so that would be 4, 4, 5, 7, 2, 5, 4, 3, 0, and 7. In 11, a formula was entered in cell B12. They wouldn't have actually typed the number 50, they would have typed a formula. What would it have been? Well, they wouldn't have sat there and said to add all of those numbers together. They would have used the sum command, which is much quicker in Excel. So that would be equal sum parentheses, and then to tell it to add that entire column together, we just need to tell it the first and the last. So B2 and B11. I would say B2 colon B11 and then close the parentheses.